Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem belongs to Momentum playlist. Please look into description. There are all the links that will help you to know your prerequisites and to understand this problem better, because everything is built on the previous material. But anyway, it is a problem about projectile, and this projectile has mass m, and it moves with the speed v0, and at some point it is separated into two, and I will move them separately. This is of course at the same, but if I start moving one on top of another, it would be too crowded. So the first projectile, it has the mass km, and k is a proportionality coefficient. It's 0.6, they tell us, meaning that 60% of this original mass is flying forward, right? And they tell us that the speed is v1, and they tell us that initial speed v0 is, let's say, 20 meters per second, and this projectile, this v1, it has a speed v1 equals 30 meters per second. The second piece, the second chart, and we of course should put them all together, but I put separately. This distance is 0 because it's just like at one point it's just like separated in two, but it will be too crowded if I draw it like this. But this is v2, and basically they want us to find v2, and of course we will do it using momentum p equal constant. This is closed system. This system in the beginning no forces, and on its own it explodes into pieces. So this projectile in the beginning impulse is mv0, and of course I do it straight along the x-axis because this is a vector form, but everything happens here along the same direction. They told us that this is original and this is the direction of this. That means that this second chart has also the speed directed along this line. We don't know this way or that way, but only this way, because if it would be directed sideways, it's impossible. This is initial momentum, and this is also along this line. So if this would be some projection of this v2 in this opposite direction or perpendicular direction, it would be impossible. It would be violated this vector form. So everything happens along x-axis, and this is initial, and we have to say that this is kmv1. This is momentum of this particle, and this is momentum of this particle, and this is 1 minus k multiplied by m and v2. So 1 minus k, if k is 0.6, and 1 minus k is 0.4. 60% is this particle and 40% is this particle. And it actually doesn't matter what projectile is. It may be some real projectile, or it may be like a atom. Atom splits in two, it doesn't happen, but if it will happen, it will be something like this. And it's very similar to what we wrote about collisions. Only in elastic collision they were all together in the end, and here they all together in the beginning. But this is the same form, and right away we can cancel m because it's the same factor here. We can divide into m, this into m. Physics is ended. Excuse me. Physics is finished here. All we have here is the mass. And very simple mass at that, because V0 is known, K is known, V1 is known, so V2 is not known, but then it's very simple to solve it. We move this to this changing sign, or if you want to write it properly, we add minus KV1 to both sides of equation. This will be cancelled and this will become V0 minus KV1 equal 1 minus K over V2. We move it here, 1 minus K over V2 equal V0 minus KV1, and we obtain V2 equals V0 minus KV1 divided by 1 minus K. And you see, it's very nice that I was able to solve it in this form, because I will analyze this result now a little bit. Of course, I can plug the numbers right away, and I can put here 1 minus K would be 0.4. I put V0 is 20, I put K is 0.6, and I put 30. And I mean to say 20 minus 3 by 6, 18, it would be 2 divided over 4. What I'm trying to say here is that if the numbers would be, like for example, K would be 0.7, for example, and I'm leaving everything like this, then I can plug the same numbers here, and this would be 0.3, and this would be 0.7, and the result would be negative, because it would be minus, I will wipe it out, minus divided 0.3. So, writing this in this form, as always, in letters, instead of plugging the numbers right away, because I can put here 0.6 and 0.4, but it will, first of all, make finding my error, my own mistake, more difficult, and secondly, I can analyze this very nicely, because I can say that if K is big enough and V1 is big enough, then the result would be negative, and negative means that the second chart can possibly fly that way, because this momentum would be so big, because mass of this particle would be big, the bigger K, the bigger this mass, and also the speed may be very big, and then in the end of the day, this particle has to absorb this momentum, so it's all equals to this, and this way this particle may be moving in opposite direction. I hope you liked it. I hope you subscribe, you hit bell, you put your question, and I see you next time. Thank you.